Moving forward to the last part of question B, finally, after 4 parts, we have to consider two quadratic functions. P of x equals to negative 2x squared plus 2x minus 10, where x takes in real numbers, and q of x, which is equal to 2x squared plus 5x plus 25, where x is takes in real numbers. Now, very odd form of a question, but here they're asking state which one of the following is true, and which one of the following statements is true, and justify your answer. Is it A, kmax of p greater than kmax of q? Is it B, the other way around? Or is it C, where kmax or their values are exactly the same? So here is something that you might realize to use is please do not take in the values of A and B from both quadratic functions and plug them in here, because it's going to take you absolutely ages to find out what exactly the values are. It is better to use something you already found. In part 2 of our question B, we have figured out that to find the value of kmax, you can simply do 2 times the absolute value of A. So that means kmax of p is simply equal to 2 multiplied by the A value of the quadratic function p, which is absolute value of negative 2, and that gives us 4. Moving on to the next one, kmax of q is equal to 2 times the absolute value of this A value. Now its A value is 2. So here, kmax is 4. Well, now you see, and you've also justified it, by the way. Statement C here is going to be correct. The maximum curvature of these two quadratic functions are going to be the same. Which I know I'm yapping about a lot, but it makes sense, right? Because for a quadratic function to have high curvature, it would need to have a higher primary coefficient in order for it to look like this. For example, this could be when a is equal to 10, when you have 10x squared. Now, if you have 1/2 x squared, you would have, oh my god, you would have a parabola that looks something like this, where the curvature is not so extreme. So that means a is the only value that actually affects the curvature of the parabola, and hence we found this expression back in the question 2, and hence, you know, the curvature of these two quadratic functions are the same, because one is facing up, the other facing down, but their curvature is exactly the same.